Yes, welcome guys to quadratic equation part 6. Okay, so don't forget we're still trying to trash completing the square. Okay, so now this is the question number 2 questions in the questions I listed in part 5, which is we need to take care of. Now I'm bringing this down. We have this question, which is n squared plus 2n. The question, it can come in two ways, like I said, though they might not mention it, except if it comes out in the theory part, in the theoretical part. I could remember that was many years ago during my time. You know, I know that came out in the theoretical part using the completing the square method. They know that a lot of people, a lot of students run away from this method. So that was why they specifically mentioned using the completing the square method, solve the quadratic equation. Okay, but in the objective part, of course, I mentioned the shortcut, which is the jump standard yesterday. Okay, in the part 5, that okay, yes, if you see it in the objective, you don't need to go through the steps and all those, but for clarity and understanding. So now let's take it one at a time so that we can get the understanding. By the time we solve other questions, to just be like more of revisions. So now look at this question here, number 2. What makes it a perfect square? Then using the complete, it's still the same thing, using the completing the square method. So now, ordinarily, we know quadratic equation is supposed to be ax squared plus bx plus c equals 0. All this a, they are representing figure. It could be 2, it could be 3, it could be 4, it could be, you understand, as normal quadratic equation, normally. So what we will now do here is that we represent, let's name this one as equation 1. Let's name this one as what? 2. So what we now do, the first thing we need to do here is that write 2. Okay, write 1 in form of 2. Okay, so write 1, that is equation 1, in form of what? Equation 2. So what we now do is that implies n squared plus 2n. Let's say we can use anything to represent it. Let's say plus, let me use any alphabet. Let me say plus d equals what? 0. Okay, so we are making it to look like a normal quadratic equation, and they are telling us what must be the value of this d to make this equation a perfect square. What must be the value? It's very simple. I named this one as equation 1. This one is the normal general quadratic equation. Okay, it can be anything. Ax squared plus bx plus c is equal. This is a normal representation too. So I'm writing 1, which is this one here. I'm writing it in form of this 2 here. Okay, so I'm just introducing this because we don't know the value of this d. Do you understand me now? So now in completing the square method, the first thing you need to do is that, what is the coefficient of n? The coefficient here, identify the coefficient. Coefficient, coefficient here in 1 above, is n. Okay, so very simple. You've identified the coefficient. The coefficient here in 1 above is n. Okay, so after you've identified the coefficient in the equation in 1 above, then the next thing you need to do is that, let's tag this one as equation 3. Okay, just to make it clear and straightforward. So the coefficient here in 1 above is n. Okay, now in this equation we have n squared, we have 2n, okay, with no power. Then we have d, which is what we are looking for to make it a perfect square. Now what you now do is that, the next step is just to say that, oh, what is the coefficient of n in 3 above? The coefficient, the coefficient of n in 3 above is 2. Do you see now? Very simple. So the first thing, we write this as a normal quadratic equation using D. It can be any alphabet. It can be E, it can be F. It depends on what you want to use in your own calculation. Okay? I write it as normal quadratic equation. And I said, okay, the coefficient, I identify the coefficient. What's the coefficient here? The coefficient, don't forget in part 5, I mentioned it that any coefficient you want to use in the question, that it depends on the question. They can use M here. They can use M. They can use J. They can use L. It depends on what the examiner wants to set. Okay, so the coefficient is n. Then the coefficient of n, okay, the coefficient of n in 3 above, that is the figure beside n, okay, the figure beside n is what? Is 2. Or don't let me use the word coefficient here. Let me use the figure. Let me use the figure to be clear. The figure, the figure beside n. Okay, yeah, that's clear. That's clear now. The figure beside n in 3 above is what? Is 2. So the next step, what's the next step? Okay, now we should find, you now say, the next step here is that we should find the half of the coefficient on the figure beside n. Find the half of the figure beside n. So let's name this as what? As 4. Okay, so you now find the half, which is 1 over 2 of 4 above. Okay, so simple. So the figure beside n in 3 above is what? 2. So we name it as what? Equation 4. Then find the half of 4 above. I don't want to mention the statement. So the 4 above is the figure beside n. So it means that implies I should find the half of what? Of 2. So which is times what? 2. Okay. So this one is same thing as 2 over what? 2, which is equals to 1. Do you see it now? 1. Find the half of 4 above. And this is equation 4. Very clear. So after that, now we can name this particular part as what? 5. So because I'm doing it like that because I want to make reference to it. So the next thing is what? Find the square of 5 above. Find the square of 5 above. So this means that that implies if I want to find the square of 5, what's the answer in 5 above? Which is what? 1. So if I want to find the square is what? 1 square, which is the same thing as what? 1 times what? 1 is equals to what? 1. So you can see now. So it means that I can now go ahead and say, don't forget, yesterday I mentioned it for jump standard, you do what? You add the square of the value of the coefficient of n. You understand? But in this case now, if you look at the square, so let me now tag this as what? As what? 6. Okay? So it means that on adding to 1 above, which means that the value that we are looking for is what? 1. Then it means that add that is add 6 to 1 to equation 1, add 6 to equation 1 above. So which implies that the missing value that we're looking for is n squared plus 2n plus 1. We make it what? We'll have a perfect square. Okay, so if you want to know whether what we're saying is true or not, all you just need to do is just you make reference to that is 3. Okay, make reference to 3 for you to be sure that what we're doing is correct. So if I want to do it now, if I want to make reference to 3, then it means that I can say n squared plus 2n plus 1 equals what? 0. So what is the value here? So it means here I can say n squared plus n plus n plus 1 equals 0 if I'm factorizing. Oh, that's how you know that yes, it has a perfect square. So it means that n is common here. I can bring n. I'm factorizing n plus 1. So here, 1, I can bring 1 out. So n plus 1 equals 0. Now, please don't forget, okay, we've gotten the answer, which is our D in equation 3. We've gotten the answer to be what? 1, following the steps above. I have to simplify this because this comes out in the theoretical part. Well, it might be in your set, and they've just mentioned that using the completing the square method for you guys, to just follow this step. It's very, very simple and then straightforward. Now, at this point, what I'm trying to do here is that I put the value of D to be 1. I'm just trying to verify for you to see that it is a perfect square. So if you look at this very well now, I'm trying to factorize this n squared plus 2n plus 1, making the reference from 1 above, like from 3 above. I've gotten my D to be 1. Okay, so now n is common here. I bring n out, n plus 1. Okay, then plus 1 is also common here. Plus 1, I've told you anything times 1 is that thing. So plus 1 is common. I bring it out, n plus 1. So n plus 1, n plus 1 equals 0. So if you look at it now, n plus 1 is the same thing. I can say n plus 1 square. That is, this one is the same thing as n plus 1, n plus 1. You see now, equals what? 0. So look at it, n plus 1 is the same thing. So if I want to use the law of indices, I'll pick the base and add the power. This is raised to power 1. Anything raised to power 1 is that thing. So I can pick the base here and just add the power, which shows that it's a what? It's a square. So it's same thing as n plus 1 or what? That's 1 plus 1 equals 0. So n plus 1 square equals 0. So it's just to verify that this is a perfect square. This is what they're looking for. You understand? It's a perfect square. And don't forget, okay, it depends on your option. Your option can say what is the value that will make this equation a perfect square. Look at the answer. Look at the question. What is the value that you can add to n squared plus 2n that will make it a perfect square? The value is what? 1, which you've calculated. Okay? The value is 1. Okay, the value is 1. But if they now go ahead and say, okay, find the expression that makes it a perfect square, just factorize it after you get the value. If you factorize it, you'll get what I'm getting here. So it's very, very simple. So for all other questions, we'll be following the same method as shown here, so that you can understand completing the square method. It's not hard at all. It's very, very simple. I have to take my time to ensure to simplify this, so that when you see it, or when you see it better later, you will be able to identify and be able to solve it. Don't forget, from the question is n squared plus 2n. I'm repeating myself again. This is a general quadratic equation. As squared plus bs plus c equals 0. And name it as equation 2, equation 1. Write 1 in form of 2. This is 1, equation 1. I'm writing it in form of 2, which is this n squared plus 2n plus d. We don't know the value of d. I just represent it. Equals what? 0. To make it a perfect square. Now, the coefficient, identifying the coefficient in equation 3 or equation 1. The coefficient here is what? Is n. It could be, I've told you, it could be x, it could be y, it could be z. Okay. Now, the figure beside n in 3 above is what? 2. The figure can change. I've told you any value on the right hand side is the owner of the sign. But because it's positive, I didn't mention. But if it is negative, I have to put negative here. But in this case, it's positive. You understand me now? So the figure beside, or the value beside n, you understand? You can use value too. The figure beside, or the value beside n in 3 above is what? 2. So the next step, and I name it as equation 4. So the next step is find the half of 4 above. I don't want to repeat the statement. That was why I named it as 4. So I'm finding the half of the value beside n. So what's the value beside n? Is 2. And I'm finding the half. So it means it's half times 2. So 2 divided by 2 will give me what? 1. Okay? From this now, find the square of 5 above. What is the 5 above? This is equation 5. So 1 square. What's the answer I got in 5? Is 1. So I'm finding the square. 1 times 1 is what? 1. Very simple. Then add 6. And I named this one as equation 6. Add 6 to 1 above. Okay, so since the answer is 1, plus 1 is here, but we don't usually put it, so it's still plus 1. So that's why I put n square. Had it been this one is minus 1, I have to put minus 1, but in this case it's plus 1. So that's why I put n square plus 2n plus 1. We have a perfect square. Now for you to confirm that it will have a perfect square, that was why I did this. This is not compulsory, but I had to show you so that you can see that it has a perfect square. N square plus 2n plus 1. If I want to do this now, 2 here, so in 2, what can go in 2 is what? 2 equals 1. You can divide 2 by 2, so 2 equals 1. Or you can also say, yes, you can also say 1 and 1, 1 plus 1. Okay, you can also say 1 plus 1. Don't let us use 2 and 1. So you can also say 1 plus 1. So this is 1n, but we don't write 1 here. So n plus n will give you 2n. So I take one n out, so 1 will remain here, and 1n will remain here. If you expand this, you will get this back. N times n, n square. N times 1, n. Okay, plus 1 is common here. So you have n plus 1 back. So that is how I was able to. So this one is what? Indices. They have the same base. When they have the same base, n plus 1 is the same thing as n plus 1. Take 1 and add the power. So which is this? So it shows that this one has a perfect square. It's a perfect square. You understand me now? So it's very, very clear. It's very, very straightforward. Please don't forget completing the square method. We will solve other questions so that you can see how they use completing the square, because you must understand this and it must be clear, so that at the end of the day, when you get to maybe jam exam, and they give you an expression that you cannot factorize like this, you need to quickly use your completing the square or quadratic formula to get your answer out. Okay, but most times in the SSC standard, they always mention using the completing the square method, because they know that most students always run away from it. Using the completing the square method, solve the quadratic equation. Thank you. Please endeavor to share, like, and comment. And if you have any observation, anything that you're not clear of, please let us know so that we can then trash it for you. Thank you.